myself Dhara from grade 9 and Rudrakshi from grade 6. And we are the quantum twins. So a quick question to the audience. Has anyone had their internet stop working right after they had to submit their homework? Yeah, tragic. But imagine that happening during a security mission. Like, if teams are supposed to communicate, but someone's got a jammer, it's like bringing noise cancelling headphones on the entire team. Boom, silence.
Okay, we'll take a practical example. So let's take it, two best friends, both grounded, worst day ever. No phones, no Wi-Fi, just a laser pointer. So we say, fine, we create our own chat system. We create a 6-bit system using laser points.
Alright, so our usually computers use 8-bit ASCII, but like when was the last time you used a hashtag or like some other symbols in a tactical mission? So we custom our own 6-bit system which has letters A to Z, 0 to 9 and a few other symbols. And right now our system is a half duplex, which means that one can talk and one can listen. And also we custom our 6-bit ASCII so that it uses less data and faster communication.
Okay, but for that we had a problem. So if I send 3 zeros, is that 1 long off or 3 short offs? To solve that problem, we created a genius rule. We call it the middle rule. So each signal is 100 milliseconds, but my friend over here checks it at exactly 50 milliseconds. Right in the middle, no confusion. And to add the synchronization, we send a hello signal, a long flash for a short one, which means, hey, status stopwatch now. Boom, perfect timing. We have created a new upgrade. So remember our chat system, it has 64 total symbols, but we're using only 37 of them, including the 26 alphabets, the 10 numbers, and 1 space key, which means we have 27 more left. We create those 27 into shortcut words. So instead of sending HELP during emergencies, we just send one signal. Super easy.
So we will be like in the future making sure that our system develops into full duplex, which means that we'll be adding one sensor and one laser so that both can communicate. And for this we'll have to upgrade from an Arduino Uno to an ESP32. And the coolest part is that our system can be used in places where there needs to be defense or security missions where people can talk with direct and secure communication.
We can also use this during natural disasters when the signal is lost, the signals are down, but the transmitter and the receiver must still be in line of sight. The greater organizations like NASA have already started using this technology in space for satellites to communicate, this makes it faster and easier to communicate.
So now we'll be showing the demo.
Our practical example has two parts, the transmitter and the receiver. So in the transmitter side, we have the laser module, which is connected to the jumper cables, which is connected to the Arduino digital pin. Now over here to the receiver side, we have the phototransistor inside, and which is connected to the jumper wires, which is again connected to another Arduino, which is connected to the digital pins. And then it is then connected to the LCD, which shows the output of the received message. And the laser module and the phototransistor are in line of sight. Let's now see the demo. I am now powering up the receiver with the battery. And this message is showing since it is waiting for us to input a message. Yeah. Now let's come over to the transmitter part. We have to connect the wire with the phone in which we'll write the message.
And then we get USB device detected. And then I have to tap this button to connect it. And then you get a message, another message connected to the device. And then we can type our message. Hi, we've typed our message, and then we click send. And then it says preparing to send hi. And then it says sent.
And in the LCD it says receiving, please wait. And now it shows our message, hi.
And in our app, we get a message for us to just make sure that we sent it, preparing to send, and then we finally get sent. This ensures that the packet has been delivered.
That's all for the demo. Thank you.
So this is the transmitter code. So once the user types some type of word, it goes to the transmitter code. The transmitter code is used for the LUT, which is like a common dictionary for both the transmitter and the receiver. And then it goes to the specific like character and then effective code for it, and then sends it to the receiver. And then how it's sent is like basically the receiver number will look like this, but it will send it like separately with zeros before, and then the last number will be the higher off. One represents high, zero represents low, and then it sends it to the receiver. And how it sends it, like the receiver does the exact reverse of what the transmitter does, and it groups the 6 bits that were separated to finally look at the lookup table and like find the characters, respective characters. And then it displays it on the LCD screen. The transmitter code.